Welcome to A Rare Reality, a podcast powered by Jordan's Guardian Angels. I'm Christina Janes, Director of Outreach and Awareness for JGA, and I am joined by our project director today, Carole Bakhos, and by Dr. Ghayda Mirzaa from Seattle Children's Hospital. We have so much to talk about today because finally, our families, it's the day we can talk to you about the new publication that's out. We've been waiting. We're so excited. So, Carole, bring us up to speed. This has been a long time coming, and we're thrilled to have it.
Yes, absolutely. We're very excited to share that our PPP to our 5D publication is out. Dr. Mirzaa, Dr. Chung, Dr. Jensen's and their teams really worked hard to get that information out. They used all the data that families have been providing in Simon Searchlight, and we're really looking forward to hearing what is it saying, what is the data telling us. So we're glad to have Dr. Mirzaa with us so she can explain it better than I would be able to.
We have the professional with us today. So, Dr. Mirzaa, tell us a little bit about what is in the paper for our families who don't necessarily know much about what this means. Bring us up to speed about the generalities of what this is.
Yeah, absolutely. Well, first of all, it's a pleasure to be here. Thank you for having me. I'm delighted to be here to talk to you and to the families about this work. This has been a super exciting and really enlightening journey, actually, in the process of writing this paper up. So as many of the families may know, that, the PPP2R5D, as well as other members of the phosphatase families, were first described in association with neurodevelopmental disorders in kids a few years ago. Now, generally in genetics and in the genetic community, usually the first few papers, which what we call the gene discovery papers, which are the first, kind of links between genetic changes within any gene and, any medical issues within children. That first wave of papers that comes along is often extremely helpful because it allows families to, get diagnosed if their child has a variant in that gene. Without these papers, oftentimes we don't know, as medical professionals, we wouldn't know that this is the cause of the child's health problems. But beyond that, so once that goal is accomplished, beyond that, it becomes extremely important and extremely helpful to not just have that knowledge, but to really understand, well, what does the spectrum look like? How do kids vary with genetic variants in this gene? Are there, different factors that cause different grades of, severity? Are there certain things that increase the risk for certain complications, like, seizures, for example, is a really important example, and others. And how many kids are out there with this condition? What are their age ranges from the time they get diagnosed to the time they get to medical care? And all sorts of questions that fall under that oftentimes, to be totally honest, it is really hard to find that data in the literature after those gene discovery, those first few papers, that first wave, if you will, comes around. So these are what we call more long-term natural history studies. These are often, again, harder to come by. They take longer. They do require, of course, first and foremost, families to be able to willing to donate some of their time to provide that information about their families and participate in those research projects. And so with this background, I think what we had been working on for the last few years, and as you mentioned, Carole, this was highly in collaboration, and I want to acknowledge first and foremost the people and the village that it took, including, of course, you guys and the families are at the top of that list. And then, of course, the Simons Foundation, led by Dr. Wendy Chung, in terms of data collection, and Dr. Jensen's. And I'll talk a little bit more, maybe as we go along, maybe we'll talk a little bit more about the different things that we kind of discovered and the interesting findings. But the past few years, all of us, I think, have been extremely busy trying to answer some of these questions. What does the natural history look like? What is that, range of symptoms and features and medical problems that families have to deal with if their child has a genetic variant in PPP2R5D? And just, uncovering all that wealth of knowledge, right, that we would need, that would help not just the medical community in figuring out therapies, but also future families. If a child gets diagnosed tomorrow, we want families to have access to as much information as possible. So this is really the scope of this work, is that in the past few years, we've been collecting data, and families have been contributing very generously a lot of information about their children with variants of PPP2R5D. We've analyzed all the clinical information. We've analyzed the genetic information as well, the type of change that occurs in PPP2R5D. So we also looked at the molecular changes. And then the third arm of it was also looking functionally at these variants and what do they do biochemically on the pathway and on the function of this phosphatase. So we kind of had three arms of it, if you will: the clinical arm, understanding the features and everything; the molecular arm, understanding the genetic variants, and we found a number of new variants, which is very helpful. And then the third one was the functional arm, which is really kind of trying to understand at the biochemical pathway. So that was the main thing that happened through this paper. Further, we wanted to also take it a step beyond, is that these are all like really fundamental building blocks in our understanding, but we also wanted to then see how do they relate to each other. The correlations, what we call correlations between clinical features, molecular features, and functional. What is the relationship between all those things? Because as we all know, biology is an extremely complicated thing. It doesn't work in isolation like that. So we wanted to look at the links between them, what we call also in the genetics community, genotype-phenotype correlations. And so this was kind of the product in this paper that we tried to report on. And yeah, it was extremely helpful for our understanding of Jordan syndrome.
Yeah, and just to echo what you just touch base. I mean, right now our families get their diagnosis and they still tell them today there's 6 known cases in the world, so that's gonna change that, because they come and they're like, we just connected to 300 people, so at least now the medical community will have that information that there's more than 6 cases in the world when we're talking about this.
Yeah, absolutely, Carole. And I will just to echo on that point a little bit, speaking on the medical community side, to be honest, these papers are types of projects in general are extremely important because, again, the first gene discovery papers are helpful, but they really don't give us the full picture. They give us a very narrow slice of the picture. And I will be totally honest as well. Publishing these follow-up papers is often really hard, by the way, because we just, I think this is a bias in the scientific community sometimes, is that, the novelty, it needs to be there, right? So if it's a novel gene, great, that's exciting, it gets published. If it's not novel anymore, it's been published before, then it becomes a little bit more challenging. But I think overall, to be honest, I think the community is also appreciating that for us to get to clinical trials and therapies, we really need these kind of natural history studies. I think that's kind of really now that awareness is out there. So for doctors, for example, seeing a child in their clinic, they're just going to look at what's published. It's really hard to have access to all the sources of information we have these days, right? And families might have some sources of information, doctors have different sources of information, and so it becomes really hard. So publishing is often really helpful, and so this paper hopefully gets us closer to that.
Okay. So you touched on variants in there. I know, Carole, you wanted to discuss that further, because what is this paper telling us? Telling us a lot of things. Obviously, there's a lot that came out of this, but we talked before about the variants that came out of this. Can you go a little further on that and what that means for our families too?
Yeah, absolutely. So, in the first few papers, only a few variants were known to cause, Jordan syndrome in kids. So these are what we call pathogenic variants or disease, in other terms like disease causing, basically. So there were only a few of them that were known. And so if a child was, tested in the clinic and found to have another variant, oftentimes the families might be given a different kind of level of information. They might hear, a doctor say, well, we're not sure you have this condition because your child doesn't have one of those very few variants that were published before. So the term that's used for this is variants of uncertain significance, which means there's a change in the gene. We don't really understand what it does. That's what it, that's what it is. Variants of uncertain significance, which in short, we usually call VUS, just to shorten it a little bit, are very common. They're a big problem, to be honest, because again, it leaves the families in limbo sometimes about, well, does my child have the condition or not? And oftentimes, again, until like these big studies come along, we deal with this quite often because labs and doctors are only relying on what's out there. So one of the values of this paper is that we uncovered a whole range of new genetic variants, new meaning that they were not published before, that we prove in the paper that they are pathogenic. So we've increased now our, kind of wealth of knowledge about the pathogenic variants by this much. Honestly, it expanded quite a bit. It more than doubled based on this paper. We've also examined a few specific variants that were called variants of uncertain significance biochemically. This is work from Dr. Jensen's team, and this has been a big goal of her team to really kind of dig down into these variants of uncertain significance and see, well, can we figure out, are they actually doing something to cause, health problems, or are they not? Are they what we call benign, meaning that they don't do anything? They're just silent changes, because any of us can have, in theory, any of us can have a genetic change in any of these genes. So she actually looked at a number of these variants of uncertain significance and was able to upgrade their classification into either disease-causing or benign for a number of them. So now this information is out there. Hopefully labs now will be able to access it and use it to update their internal databases. And so if a child tomorrow gets diagnosed with one of these, labs have access to more up-to-date information about these variants. So I think the overall, kind of accomplishments were that we added a whole number of new pathogenic variants that are extremely helpful and important to know. And then we've also were able to resolve some of these VUSs that are quite problematic and difficult sometimes to deal with. So we have more information about them, and a couple of them turned out to be not doing anything. A couple of them actually turned out to be probably causing, health problems. So now we know that.
So just to make sure families know exactly what we're talking about, when we're saying variants, it's what we've been referring to within the community as E198K, D251V. It's these, specific flavors of the gene mutation, just so we're fully clear what we're talking about here. But I know in the paper, the variants, some of the more common variants were grouped into 3 subgroups. Yes. And kind of shown how severity is impacted based on that. Can you speak a little bit to those groups and what they mean?
Yeah, absolutely. So I will say, and Carole, to your point about variants, yes, you're absolutely spot on. Sometimes the other phrase kind of we use for it is genetic changes, right? A variant in general means genetic change. It doesn't mean it's doing something, but in this context, that's why we always add sometimes the word pathogenic, meaning it's doing something, because again, all of us have genetic changes in our genome. It's a fact of life. But yeah, exactly, Carole, and thanks for clarifying that. And so yes, so what happened as well is that because we found now so many more variants, when we first had very few variants, it was really hard to look at their function and classify them into groups, right? If you only have a few, how can you divide them into groups and try to correlate them, with health problems? But now that we have a lot more, we were able actually to stratify them based on their biochemical function. And a lot of this work, again, was led by Dr. Jensen's group, actually. These are all, as we all know, this gene is a phosphatase. This phosphatase binds to certain substrates. So based on their binding abilities in culture in the lab, we were able to actually identify that these variants overall kind of stratify into 3 subgroups, depending on how much their binding ability is impacted. Usually what happens is that their binding abilities, because of the genetic change, it is reduced. That's the common mechanism, is that they just don't bind as well as they should. And so then it's just a matter of, well, what are they binding to and how much of it is affected? So based on that, we were able to find 3 subgroups based on their binding abilities to something called a C ligand, something called liprin, which is another molecule within the cell, and then both. So there was one group, which basically one group of genetic changes or variants that demonstrated a reduction in C ligand binding. A great example is the very common E198K variant, for example. And then the second group showed decreased liprin binding, and then the third group showed a reduction in both. And so we were able to kind of see that, yeah, they change, their binding abilities changes in a variable degree, but some variants go together, if you will, in these subgroups. And what was really helpful is that, this was really important information, that we understand them biochemically, what they're doing, because that's been one of the biggest enigmas and mysteries with a lot of these phosphatases. I mean, as we all know, and I'm preaching here to the choir, I think the phosphatase field that has been going on, research has been going on into the phosphatases for decades, right? I mean, one of the biggest challenges is it's the fact that they have so many functions in the cells and they bind to so many things that it becomes really hard to kind of decipher, okay, what are they binding to exactly, and how does that cause health problems, neurological problems, the whole range of things. So the substrate binding is really important. So the fact that we're able to not only see that it's reduced, but also see that there are differences, that not all variants, if you will, are created the same. Some variants reduce one substrate, other variants reduce another. And then others might not reduce binding at all, in which case that can actually cause us to really think about other mechanisms that they could act on. But beyond that, what we tried to do is take it a step further, is that to say to go and basically say, okay, so we know that now there's reduced binding, different flavors of it, if you will. How does that relate to the child's, to a child, any child's health problems? Are certain groups more likely to cause specific problems or not? And we were able to see some correlations there. So we saw that, for example, E198K and a few others in that group unfortunately can cause a few more significant neurological problems, for example. Other variants might actually not cause as much problems. Now, I will say this is extremely helpful and it's important, but at the same time, I don't want families to also take away that to say, oh, if my child has the E198K, that means that's it. This is severe. This is the worst group of variants or something like that. These are kind of what we call, again, correlations, like that it gives us a glimpse into how they could act and how they could affect the body and how they could affect the development of the brain. But there is a lot of also individual variation. Every child is different. They might have other genetic changes. The rest of their genome is different. Their environment is different. So I want to also make it clear that a lot of these genotype phenotype correlations give us a little bit of like a framework. It gives us a map, if you will. But within that map, we still have a lot of variability. And what that means is that when we see a child in clinic, we're not going to just say, oh, you have this variant that in this paper it says it's severe. That means that's it. The prognosis is bad or anything like that. None of that. What that means is that we have an idea how biologically it could function. But if we see, for any child, we'll usually, of course, assess them individually as well. But this was kind of the big framework like that really allowed us to just begin to understand the landscape of, okay, variants can fit into one of these three buckets, if you will. There might be more mechanisms coming down the line in the future. If we find other variants, new variants, we might learn more. But we now know that they have different substrate abilities and they can be reduced to variable degrees. And when certain substrates are reduced, they can cause, in some children, they can cause more neurological problems, for example, and a few other things. So that was kind of the general learning that we had from that.
Yeah, and I think that's a great takeaway too, that it's this doesn't define like the path for each of our children, right? This is just kind of making us understand it at that higher level, but and the paper covers that as well. I mean, you can see the spectrum in violence scores as an example within each of the variants. So there's definitely a large spectrum to and maybe we can speak about like how to support families through whatever variant that is. What's the best thing for families to do to support their children?
Yeah, absolutely. And I think that's really one of the big goals out of this, is that if the more we can be specific about what are those range of challenges and health problems we have, how variable they can be, that is all extremely important for like really tailoring then any therapies we use. They have to be tailored to the child and they have to be tailored to the variant. And so scientists hopefully can use this variant information in their drug design kind of work, right? So I think this is all kind of really getting us closer to that goal. And then of course it's important to remember that, for other families, they might actually get diagnosed, in the future. And so it's really the more specific information out there about these variants, labs can use that information to give them an accurate diagnosis. So when we're saying that, oh, these are new variants, and look, functionally and biochemically, this is their effect, it leaves little question that, well, this variant then is doing something. So if a child is found tomorrow to have this genetic change, hopefully they won't get this gray zone result, this variant of uncertain significance, result, which again leaves the family in a really confusing, I think, space. So hopefully that information can be helpful in that regard too.
Let's touch a little bit too on what this means. We'll talk about families in a minute, but I think that what does this mean for the medical community to receive something like this? How is this used, as a tool? You touched on it for potential drug design, or but for all of our families have a number of clinicians who are working with them and trying to best support these children. So how do they use this as a tool for themselves to think, okay, we can take this somewhere?
Yeah, absolutely. So to be honest, and as I may have mentioned a little bit, I think that the benefits, hopefully, we hope to extend to several aspects. The first one is like we just talked about, is on the diagnostic side. Again, we want to minimize diagnostic uncertainty for families. And so the more we publish on the number of variants and the scope, of the health concerns and things like that, the better it will be. This information we expect, and I say this as actually both, I'm both a neurogeneticist in clinic, and I'm also co-director of a molecular diagnostic lab, at the University of Washington. So I say this as somebody who wears sometimes two hats. On the clinical side, I see families, and then also on the laboratory side, I analyze data and I report out variants and things like that. And our team reports, exome sequencing all the time and everything. So the first benefit is really on the diagnostic front. We want this information to be as widely disseminated as possible. And hopefully now, not only through the paper, but usually what happens is that there's a lot of databases online that go and mine the literature. So they hopefully will see this paper and they will add all the new variants into their databases to then update, all of these kind of information sources. So we hope that labs will have less of gray zone results, more certain results, and then providers will also be able to access that information. So that's just that is the most, and I spend a lot of time talking about it sometimes on the diagnostic side, even though it's not really what people think of as exciting to get us towards therapies, but it's fundamental for families, so I think we really need that goal accomplished, is to minimize diagnostic uncertainty for families. So that's goal number one, and I won't spend, I promise, as much time on it from this point on. The second goal is really what we call natural history data, which is what this paper is providing. These are now instrumental tools, and it's been known for a while, to be honest, but now we really kind of, I think the whole field, especially for therapies for what's called so-called rare diseases, it's well beyond awareness now that natural history data like this one are extremely valuable for what's called the preclinical trial phase. So as we're gearing up, we're trying to find drug targets, and we're trying to find the best therapies that are targeted, molecularly targeted for this condition, and not just band-aid solutions. This type of natural history data is really valuable because it gives, clinical trialists, researchers, drug companies, it gives them a rich kind of source of information about, well, what could be the therapeutic goals? Should we be aiming to treat, seizures? Usually the answer is yes, but it really provides the data to support that. What other things are there? Is it tone problems? Is it feeding dysregulation? Sleep problems? Is it a problem in the structure of the brain? And this is often also a fundamental question, because a lot of times, and this is something we've kind of dealt with over the years, sometimes when people assume, people, including the medical community, that the structure of the brain is abnormal, that then the chances of having a therapy is less because the child is born that way, it's a structural difference and things like that. Well, we analyze brain MRI data in this paper, and this is also thanks to the generosity of the families who sent us brain MRIs from their kids. we didn't find a lot of structural abnormalities. Only a few have structural abnormalities. Most kids might have a bigger or larger head size, but the structure of the brain on their MRI scan is normal, so that's helpful. So there's all sorts of like what we call natural history data that are extremely important in the preclinical phase, if you will, while we're gearing up to clinical trials. I will say now we're looking now at the horizon. So now we're already looking at the next step, which is we want to get closer to clinical trials. We want even more natural history data, more preclinical data to allow us to now get to that final stretch where we actually have targets and drug targets and things like that. So we're already now looking at expanding the scope of the data collection we're doing to even have more information. And this, I think the scientific community, particularly people who are doing, all the modeling, whether in animal models or in cell lines, the team that many of these scientists are, of course, part of the Georgian syndrome, amazing community. This information becomes really helpful because then they know, okay, these are the specific variants that we want to model, and this is their biochemical effect. We've already demonstrated that. So now we can actually dig deeper into the biology and use that, of course, for for modulation or modification by therapies and things like that.
Yeah, I mean that full cycle, right? It starts with our families and then ends with our families. We provide that information that our team needs to do their work, get us to, clinical trials, treatments, and then that loops back to us, So we're really fortunate to have such a strong group of families and communities that are willing to do that. And I know this paper covers 73 of our families. We've since have a lot more of our families that have joined Simon Searchlight. And also we collected data at the conference, right? We collected that second level of data assessments. Many of our families that were at our conference are doing that. So I think we're gonna see an updated version of this hopefully in the near future. But can you touch base a little bit on what our families need to do to contribute to that going forward?
Yeah, absolutely. So first of all, I want to say a huge shout out to those 73 families. The science is indebted to them. They have advanced knowledge about this syndrome forever. This is extremely valuable, and I cannot overstate this because, and speaking as a geneticist, having papers with, I know 73 might seem to an outsider, might not seem like a lot. And we certainly want to get more, as you're saying, Carole, and we'll get to that. But I will say that having papers, and as someone who's been publishing now for 15 years, I've been working in this field, and I try to publish and things like that. But having data from 73 families with the richness that we had, it included all the systems basically, and all the health history and the seizure information and the Vineland scores and all that. This wealth of information from each and every family that they were willing to provide is really, it's awesome. It's amazing. So I want to, really give a huge shout out to those families, your efforts. And, I know sometimes life is crazy, but that was not in vain. That benefited science and families, moving forward forever. So that's one thing. So now moving forward, exactly as you mentioned, Carole, and I want to congratulate, honestly, I want to congratulate you guys on what happened in the family meeting, a few months ago, in that now we want to take it further. Science is an ever progressing, movement towards more advances and more, discoveries, and it never stops. And we certainly don't want to stop. So I think the next phase that we're looking at is not only collecting, so we want to collect more data. So any new families that get diagnosed, no matter if their child has one of the known variants, it doesn't matter. We want to learn about everybody. So even if your child has the same, E198K, let's say, or something, don't think that, that means that's it. We have the knowledge, we're done. Absolutely not. Like I mentioned, part of the scope of this is to understand the magnitude of this, right? And how it affects children in different ways, and how many of these variants are there. So really, any family who has been diagnosed recently, and also some of the families who have already been engaged and involved, and they've been contributing and being so generous with their time. Another valuable thing that they could really help us out with is that we want this long-term data. We wanted to understand long-term the consequences. as a pediatrician, one of the biggest biases that happens in the pediatric genetic literature is that oftentimes, as kids, what we call age out, right? Which is a great thing. We want to see our kids grow up, but when they leave the pediatric, when they graduate from our care, we oftentimes also the literature becomes biased in that we don't have adult data out there, right? That's been a huge problem, not just with Jordan syndrome, but it's a huge problem in genetics overall, is that long-term, especially adult information about health issues and things like that is often lacking. And so we want to learn from everybody. And so for families who've been involved, whose kids are getting older, we'd love to hear from them as well. And for families who are getting diagnosed now, and just now starting to get engaged, we'd love to learn more. And so the more families can, go to the Simons Foundation and be able to participate and share any data about their kids. And all of it is, as you all know, like all of it is like protected information. No private information is ever disclosed to any of the anybody really. Please do so, because we would love to learn. So we want to keep going with the data, the same data we collected actually in the first phase, but we want to even expand further. And that's, I think, one of the things that was accomplished really nicely in the family meeting, is that now we want to also collect even more important information. So the families that had their EEGs, EEGs done on their kids, the families who had a lot of specific assessments, with motor movements and things like that in the family meeting. These are all extremely valuable what we call standardized tools and assessments. So these are not chosen at random. These are extremely helpful standardized tools for collecting preclinical natural history data to define the therapeutic endpoints. And we want to collect as much of those as possible. And I think that'll be super helpful. We're already doing it. This is already happening. And by we, I mean the team here. A lot of progress has been made through the family meeting, which was amazing. It was one of the most remarkable things I've seen personally in my career. We want to keep going, and we want to do more for sure.
Sounds like we have homework to do, Christina.
I think so.
No pressure.
Same thing. I'm like, okay, well, thank you to our families for participating. And now let's move on to the next zone here. So yeah. It's exciting though. And it's exciting to have something that is tangible, that they can really utilize. Our families can really utilize. The medical community can utilize this as well. So this is an exciting, important step. And I hope that our families feel the same, so that that these families are endlessly willing to give. And so I hope that this inspires more of that too, to really see that this is happening, that it's moving, and that you guys are doing incredible work, as per usual. So thank you. Carole, anything else that you want to touch on for our families?
Well, I just want to also mention that Dr. Mirzaa talked about these databases, and where the JGA team is not going to wait for these databases to hopefully get updated. We're going to know what they are and go after them and say, this is out, please, let's work together on making that happen. I mean, this is very important. Maybe in the last minute here, can you just touch base about our global community? Because sometimes our global community feels a little left out, because like, what does that mean to us? But that paper is not just available in the US, right? Can you speak a little more what that means for our global community?
Yeah, absolutely. So certainly we would not want that information to be just limited, and it's by no means limited to just the US. I mean, obviously the research actually spanned so many countries. And I think that's one of the beautiful things about the Jordan's Guardian Angels community. Trust me when I tell you that there is absolutely strength in the fact that it's a global community. It's extremely instrumental. And I want to actually add that as a geneticist, in the past year or so, this has been, we've had an awareness and appreciation for many years, but it's actually peaked in the past year or so, how important it is for us not to limit our studies and bias. Essentially, we bias ourselves when we do that, right? If we limit our studies to a certain geographic area or a certain population, if you will, or a certain, ancestry or ethnic background or any form of, limitation like that, or a narrow approach like that, we really do bias. We bias ourselves, we bias the scientific community. We then, a lot of families might not have access to the information. Nobody wins that way, right? So we want the opposite model, which is to actually increase our strength as much as possible. And there is absolute strength in the diversity of the community and the fact that it's global. And so the more we can definitely collect information and understand from families all over the world, the better. Now, having said that, we also have to be practical and acknowledge that there will be, unfortunately, limitations maybe and differences for families in different countries in the accessibility of some of the information. So when I say, for example, some of the databases, so some of these databases that we talk about, that hopefully will deposit these data, many of these, by the way, are available in countries across the world. I have a family that comes from the Middle East, and I know a lot of providers and colleagues in the Middle East, for example, and they have access to some of the same databases I have. So it's really helpful that way. So we hope that in terms of their medical doctors and their labs that they're working with, hopefully we hope that there aren't huge barriers. Acknowledging, though, that sometimes that may not be the case. Sometimes there might be barriers. I think the key here is to be resourceful as much as possible, and we want to disseminate this information as much as possible. So certainly, we would want doctors, seeing families across the world, to be as aware as possible. So, and that's why I think we welcome anybody reaching out and saying, I have a question. We absolutely will welcome that, just to kind of try to break down and break through some of these barriers, right? Because there might be some barriers, some institutions. So for example, I'll give just one example of that. Again, just to be really practical. So, we know the reality out there is that some institutions, for example, some medical centers and even in the country and in the world, might have some, institutional access problems towards papers. So some journals might not provide access, depending on publication kind of rights and things like that. But this is a factor. It's out there in the world. And so some institutions might not have access. So doctors might not be able to access certain papers. And that's an issue. And this is something that actually the whole field is actually trying to improve as well. And as a result of that, then families might not have access. If their doctor doesn't have access to the paper, they might not. But hopefully what we would hope is that would also be, we have other sources. We have a community here that is an extremely valuable source of information. Like you said, Carole, I think that's one of the biggest things. And oftentimes I will say, families sometimes teach me a lot more about what's out there than I might not, I might be aware of, right? Because there's connection and there's community and there's access. So certainly I would say for all families who are, global families, your contribution and your involvement is extremely valuable. And this work actually cannot continue without your involvement. And if you run into any, barriers or any issues or anything like that, please share them with the community, share them with us. The more we talk about these things, the more we can figure out ways to overcome them. In terms of data sharing and data availability and things like that, we've come a long way. We could still do better, but hopefully this information should be widely, available now. I would hope so. I don't know. I hope, Carole, this kind of helped address that a little bit.
Yeah, so we want our families to contribute their data, but also take that publication, and every specialist, every doctor, every pediatrician you see, say, hey, did you know this is out? How can we share that with your team, with the hospital, with everyone else? I mean, it has to kind of, we have to help spread the word. So that's very valuable. Thank you.
Of course. And Carole, if I may add one other item, actually, one other point to that as well, which is hopefully helpful, is that as the families may know, myself and Dr. Wendy Chung and a few others, we wrote something called the Gene Reviews article, which is widely available. Anybody can Google it. You don't need a login. You don't need a password, right, to access something called Gene Reviews. And it has the Jordan syndrome, chapter that talks about everything, related to care and, variants and things like that. We wrote that a few years ago. Gene Reviews updates these chapters periodically, usually every 4 to 5 years, because it's supposed to be a dynamic source of information. And so hopefully now that we have this paper out, we will be able to add all that information into the Gene Reviews chapter as well. So I just want to make the families aware, because anybody with an internet connection can access this. It doesn't require, it's not behind any institutional, thing. It's available with anybody who can just open Google basically and just look up Gene Reviews. So also that will be something we will do definitely in the updated version of the chapter. We will incorporate all that information, and they can share that link with any doctor, like you said, Carole, any doctor, any school, teacher, anybody, therapist, anybody who they think that they need to learn this information, they can share it with them, the link, and hopefully that information will be accessible to them too.
Perfect. We'll make sure our families have access to everything in the Resource Center too. One-stop shop, if you will, for all things that they need. So again, thank you. Thank you both so much. I think we've covered a lot today for our families, and we're looking forward to spreading the word even further, bringing more data in for you as well. So thank you, Dr. Mirzaa, for all that you do, and to our research team, thank you. We couldn't certainly do this without you. And Carole, thank you for you always.
Thank you both. Dr. Mirzaa will be finding you with questions if families have any, but thank you for your time today. We love you, and just looking forward to more.
Thank you so much. Thanks for having me. And thank you both for all of your efforts, and thanks to the families always.
Yes.
Thanks.
And if our families have not heard our podcast, please check it out. Apple's podcast, Apple's podcast, guys. Boy, it's Monday, isn't it? Apple, Spotify, Google. You can find it on our website, jordansguardianangels.org, also on YouTube with translation services for our families around the world. So thank you both again, and we will see everyone again soon.
Thank you.